In this video, we'll look into promising LoRa module, that is RYLR998 from Reyax technology, and learn how to send and receive LoRa messages between ESP32 and ESP8266. All of the programming will be done using your favorite Arduino IDE. So stay tuned until the end of this video to get all the steps right. Hello everyone, welcome to IoT Frontier. My name is Hariharnath. Let's get started with the video. First, we'll try to understand the LoRaWAN. So LoRaWAN refers to Long Range Wide Area Network, and this is very popular LPWAN protocol known for its long range capabilities and low power consumption. It operates on ISM bands, which is unlicensed and free to use, and this is managed by LoRa Alliance, which is an open non-profit association of members that collaboratively work on this specification. Now let's look into the LoRaWAN stack. So here we need to understand one important point, that is there are two layers here. One is physical layer, another is the MAC layer. So LoRa is called as physical layer, LoRaWAN is the MAC layer which is on top of this LoRa. So for example, this module which we are talking about today, that is RYLR998, is the LoRa module, not a LoRaWAN module, because it doesn't have this class A, B, C MAC options and the capability to communicate in this layer. So it is only talking in this LoRa modulation in this frequency range. That's it. So next thing is LoRa module. So the features of LoRa module we are going to talk. So this is having 868.915 megahertz LoRa antenna and transceiver module, which means that for India we have 865, that is also mostly going to work. And then the MCU that it has is Novoton, and Semtech LoRa engine is there, and it has high sensitivity. So this Reyax RYLR998 can be controlled easily by 80 commands. It has a built-in antenna, and also command supports data encryption. And these are some of the important specifications that are needed, so that I have mentioned here. So next we can see what does this RYLR998 support. So first, it supports point-to-point LoRa communication. This is what we are going to test in this demo. Next, direct peer-to-peer messaging, and it has simple UART 80 command interface and basic LoRa modulations, which is that CSS, that is chirp, spread, spectrum. And then if we come to the demonstration that we are going to do today, we are going to demo the point-to-point LoRa messaging using RYLR998 LoRa module with Arduino IDE. So what we are going to do is, we are going to use a button for each of the module. One module will be controlled with ESP32, another module will be controlled with ESP8266, and each one will have a button and an LED connected to it. So whenever we want to start the program, so both RYLR998 will be started, and then they both will be ready to send and receive the messages. So first, to send the message, we have to click on this push button. When we click on this push button, message will be sent from one module to another module, and then the LED will be indicated or blinked so that the message is received, kind of indication. So for that, these are the hardware and software. So software refers to Arduino IDE and its setup that I'll be showing you, and the hardware, all the things that I have already mentioned are in the hardware. So first is the ESP32 circuit diagram, and here you can see this is RYLR998 module. So it has 5 pins. So we are not going to use this reset pin. So we will be using this VDD, ground, TXD and RXD. So VDD will be connected to the 3.3 volts, and we should not connect this RYLR998 to 5 volts. It should only be connected to 3.3 volts. And then ground to ground, and TXD we are connecting to GPIO 16, and RXD we are connecting to GPIO 17. And then button we are connecting with GPIO 4, LED connected to GPIO 2. And the remaining pins of button and LED are connected to ground. Here we are using one 220 ohm resistor. Same way we are using ESP8266, and here the only GPIO pins are differed and remaining all setup is similar. So some of the important points, as I mentioned, that RYLR998 operates only on 3.3 volts and we should never connect it to 5 volts. And both modules are set up with 115200 baud rate, so we have to make sure both are in that baud rate. And another important thing is we need to have different addresses for each of the module, that I'll show you when in the code, and also it should be having common network ID, that also I'll show in the code. Some of the important points here we can see is AT commands. So AT commands are some things from which we are able to communicate and configure this LoRa module. So some of the points that we can see, or the commands we can see here, is AT. And if you send AT command, so the board LoRa module will respond with OK, which means that it is responding properly and AT commands are working. And if you want to set the address, we can set between 0 to 65000 using AT plus address equal to with the value. And same way, network ID has to be set, band has to be set. For India, it's 865 megahertz. So we have to use all the zeros, that is 6 zeros. And then AT plus send command, we have to send the data to the specific address. So these can be shown while we are doing the programming. So now let's look into the program. So for that we need to open Arduino IDE. So there are two Arduino IDEs that I have opened. So one is ESP32, another is ESP8266. So before continuing to the program, so we have to do some configuration for Arduino IDE to make use of ESP8266 and ESP32. So go to File, Preferences. We need to add this additional board manager URL. So open this and you need to find out that ESP8266 and ESP32 both are available or not. If not, you need to use both of this JSON and click on OK and click on OK. So once you have done that, it will take some time to load, and after that you need to click on board manager and go to ESP32. So here you need to install ESP32 by Espressive System, and next thing is ESP8266. So this also by ESP8266 community, so you need to install it. So once you have added these, you can go back to the tools and you can find different boards are available, that is ESP32 and ESP8266. So now this is ESP8266 code. I need to set up this board. So for that I need to select the board, that is first I have this node MCU board, that's why I'll select node MCU, and this is the COM port that I'm using. So if you are connecting both ESP8266 and ESP32, you can first disconnect one and try to understand which one is which. So right now I have ESP32 available, which means that is COM3. So again I'll connect ESP8266 as well, and that will be COM4. So this is COM4, and I'll do the same for ESP32. So here we can see this is ESP32 dev module. So I have selected that, and COM3 I have selected and clicked on OK. Now the configuration is done. The code for both of the modules is almost similar, just the GPIO pins and the LoRa configuration might be different. I'll explain that. So first we'll go through. We have to include hardware serial for UART communication, which is used in LoRa. And next we have, these are the GPIO pins we are going to use for TX, RX, LED and button as per our circuit diagram. And then we have to configure LoRaWAN. So this is the ESP32 board. We are considering ESP32 board as node 1. So we are giving address as 100. And destination address is ESP8266 as a node 2 with 200 as the address. And network ID, as I mentioned, it has to be same. So I'm using 5 for both the devices. And frequency band that is allowed in India is 865 megahertz. So I'm using 865 with followed by 6 zeros. And then we are using hardware serial, which is mentioned as LoRa serial. The variables we are going to set up, and in the setup function So we are going to start the serial as well as LoRa serial, and we also provide the pin modes. So pin mode of button, we are going to put pull up resistor. So it will be using internal pull up resistor, and the pin mode for LED is as output. We are making LED pin first as low. Next we are going to set up the LoRa. This function is available here. So in this setup of LoRa, we are going to do all the configuration of 80 commands as I mentioned previously. So 80 plus address is equal to LoRa address that we have mentioned in the constants. Same way network ID, band and the output power as well as parameters for verification will be done. And this is the function, that is send 80 command function. So that is defined here. How are we going to send the commands? So first, for sending the message, we are going to use 80 plus send, and that will be sending the message to LoRa serial and going to clear the buffer and send the values. Same way we are going to use receive messages. So in the receive messages, we are going to wait and read the LoRa serial for any new messages and then parse those values. And then if we have any kind of message received, we will blink the LED 3 times. And if you are sending message, then in the send message you can see blinking 2 times. And this is the check button. So whenever we want to send a message, we have to click the button, right? So for that we have mentioned this debouncing logic to send the message that we are sending hello from ESP32, and the count will be shown, and also giving 5 seconds as a delay so that we don't send messages too quickly. And in the loop function, we have this check button always running and receive message always running. Now I'll try to explain you the ESP8266. So ESP8266, here the only difference is LoRa address. We are using ESP8266 address as 200, destination of ESP32 as 100, and remaining everything is same. Here also the GPIO pins will be differed. So based on the circuit diagram I mentioned previously, you can start connecting the hardware. And once you have connected the hardware, we can connect these devices to the computer with USB and then start programming. So first I will start ESP8266. I'll open as 2 windows, and here also ESP32 I'll be programming. So both will be compiling and uploading the code. So if you see, serial monitor got automatically opened. If it is not opened, you can click on this serial monitor to open that. So now it is trying to do the initial setup, that is 80 response is okay, 80 address 100, network ID, then band, parameters, everything we are able to get properly. And then it is saying waiting for incoming messages. So it is same way here also, it has stopped for waiting for messages. Now we need to click on the button to send a message. So first what I'll do is I'll try to send the message from ESP8266. So now I have sent the message. You can see the LED blinked on the ESP32 after receiving. Again I'll send the message from ESP8266. So now I didn't receive, which means that we have to wait at least some time to settle down. So that's why we didn't see any message. Now after 10 seconds, I'll try to send another message from ESP8266. Now I can see the message has been received in ESP32. We can also see the strength RSSI and the signal to noise ratio of 11. And even the reference is clearly mentioned here. So if we are sending message, it is going to blink 2 times, and if we are receiving the message, it is going to blink 3 times. Now I am trying to send from ESP32. This time I didn't receive on the ESP8266. Again I'll try to send. This time I have received on the ESP8266. So this has sent a count of 2, and here the count of 2 with the RSSI and the SNR value is again visible. So by this video, you have learned how to send and receive messages using LoRa module, that is RYLR998, with your favorite Arduino IDE. And that's it for today's video. If you found this video informative, please type helpful and smash that like button. If you are interested to learn ESP IDE programming with VS Code, then this is the playlist that you need to follow. Your support means a lot to us and helps us keep creating more content like this. So please subscribe to the channel and hit the bell icon. Thank you for watching, and I'll see you in another interesting video.